Imagine standing on the shore of a beautiful lake only to see the water turn a sickly green, fish struggling to survive, and the smell of toxins in the air. What looks like harmless pond scum is actually a dangerous phenomenon threatening aquatic life, drinking water, and even your health. This is the hidden menace of harmful algal blooms. Algal blooms are created in multiple different ways, but the biggest is through rain runoff that transports fertilizer from farms into local bodies of water. Other factors that increase algal blooms are sewage discharge, excess nutrients like phosphorus, and warmer temperatures. Lake Erie is one of the most affected lakes currently covered by over 180 square miles of algal blooms. The algal blooms are toxic to animals in multiple different ways. They are toxic when eaten by marine life, which can work its way up the food chain, killing larger animals. This also has an effect on businesses that surround this lake. Also, Lake Erie is home to four water intakes that allow for water distribution around Cleveland, Ohio. The water is affected by the algal blooms, which can be toxic to humans just like the fish. These toxins can cause skin irritation, respiratory issues, and death if not found early on. While not all algal blooms are toxic, the ones that can be have a very drastic impact on the environment, so it's important that we find a way to stop the spread and eliminate the blooms before they're irreversible.
It may seem obvious why algal blooms are harmful, but it is important to note what the exact causes and effects are. Eutrophication is the name of the process that occurs when excess nutrients are introduced to a body of water. The introduction of nutrients prompts immediate and vigorous plant growth on the water's surface. This layer of growth not only diminishes recreational value and plugs any potential drainage pipes, but lowers the oxygen content of the water. Lack of oxygen kills native fish and plants, also affecting species dependent upon them. Ecosystems are fundamentally interconnected, meaning that if eutrophication is detrimental to one aspect of the environment, i.e., fish, then the ecosystem as a whole is affected. When the algae begins to decompose, there is also a spike in the carbon dioxide content of the water and air, which can affect the vegetation. This then affects the rate of erosion, which further affects the surrounding human population. Not only do the Great Lakes contain an estimated 20% of all of the world's fresh water, but Lake Erie alone generates over $1 billion a year for Ohio and Canada in tourism, boating, and fishing. Toxic algal blooms can mean strict restrictions on the drinking water for the surrounding areas in addition to hurting the local economies. In 2011, $71 million were lost, with Canada alone being estimated to lose $5.3 billion in the next 30 years.
Algal blooms are severely harmful to the environment as they impact water quality and aquatic ecosystems. Specifically, the toxins that are created by algal blooms can kill fish and other aquatic animals. This occurs when their growth blocks the sunlight getting into the ocean, which creates hypoxia, better known as dead zones in the water. These dead zones block oxygen from getting into the water, making the area unlivable. Moreover, when the algal blooms die off, they consume the water's oxygen, which takes it away from aquatic animals. When the concentration of dissolved oxygen decreases to a level that can no longer support aquatic life, dead zones form, which causes animals to leave the entire ecosystem behind. The long term effects of these algal blooms not only harm biodiversity, but also impact the health of human populations and local economies, underscoring the urgent need for action to prevent and manage algal blooms.
There are several methods for reducing agricultural runoff that have been developed that target different sources. One of these is using no-till farming methods. The conventional method of preparing soil for planting crops churns the soil with a plow to aerate the soil and control weed growth. However, the no-till strategy plants the crops directly in the soil so as not to disturb the soil surface, so it is less likely to be eroded in runoff. Another benefit of this is reducing carbon emissions, both because of the removal for a need of plow fuel, and it allows soil to hold onto carbon instead of releasing it into the atmosphere. It is also beneficial for farmers to test their soil for nitrogen and phosphorus contents. This way, they know almost exactly how much is necessary to add, and excess nutrients will not be rejected and carried away in runoff. Another farming strategy that is becoming more popular is the use of cover crops during the off-season, fall and winter, to take up nitrate and water from the soil and make the soil more resistant to erosion. There are also ways farmers can combat algae blooms that have to do with the instrumentation they use. One of these is changing their drainage systems from conventional to controlled. The way the controlled drainage system works is that it limits the amount of subsurface water that enters the drain by raising the level the water has to reach in order to exit the soil and go downstream. The amount of water drained can also be reduced by simply raising the drainage systems closer to the surface and reducing the frequency of these drains. Another instrument that can be used to reduce nitrates in the water supply is bioreactors. Bioreactors take water from the subsurface drainage system and direct it to a pile of wood chips or some other carbon source. From there, denitrification occurs when microorganisms consume the carbon and transform the nitrate from the water into a gaseous nitrogen. According to the Iowa Agriculture Water Alliance, this method is proven to reduce the amount of nitrates in the water supply by 43%. If the area surrounding the drainage outflow has a riparian buffer, a saturated buffer may be used as an additional protection from nitrogen. Vegetated riparian buffers can denitrify the water using a water control structure that receives water directly from the non-perforated drainage pipe and sends water through a perforated distribution pipe, pushing the water slowly through the vegetated buffer. This has specific requirements, however, which are the vegetated buffer must be at least 30 feet wide, the drainage system must drain enough area to provide sufficient flow, the soil must be loamy because clay will stop movement and sand will allow water to move too quickly, and there must be at least 1.2% of organic matter within the top 2.5 feet of the soil. Wood chips can be added to encourage denitrification.
With these pressing concerns, it's a good idea to ask questions that spark innovative solutions. Some examples of these questions that raised a discussion are: 1. How can communities and policymakers work together to monitor and manage water quality to prevent the reoccurrence of algae blooms? 2. What immediate actions can individuals take to reduce their impact on nutrient pollution and help protect local waterways from algae blooms? And 3. What new technologies or strategies could be developed to detect and treat harmful algae blooms before they become a serious threat?